All right, we're a bit late already, so let's get going. Welcome, my name's Daniel, and I'm going to speak about something completely different, mostly. Looking at what we've heard and seen so far, I have to do some responsible disclosure up front. It's been about 25 years since I compiled my last Linux kernel, and also I'm mostly going to speak about other people's work today, but anyways, maybe something different for the next 20, 30 minutes. All right, it's hard to kind of find a role for myself, but I do something like what it says here, technology strategist for ETAS, which is a subsidiary of Bosch. And what I want to talk about today and kind of set the scene also for the discussion that we have after Robert's session that will build onto this, I want to give you a couple of thoughts to hang on to about software-defined vehicle and what that might be. I don't know how many of you guys, other than the logo on the T-shirt, have been in touch or are in touch with something automotive. Okay, so if I make too many assumptions, please shout. But also, again, after Robert's session, there's going to be, opportunity for discussion dedicated on whatever you want to talk about. So you can also take any questions there or any comments. Okay, I want to give you a couple of thoughts what SDV, that software-defined vehicle thing, what that might be or like what that might mean. I want to talk about, quickly give you kind of the lay of the land about something that's close to my heart, which is the Eclipse working group for software-defined vehicles. Based on that, and again, another couple of thoughts about automotive-grade software, quote unquote, and open source. And is there something there, or like what might the relationship be, or like do these words even make sense in the same sentence? And the last section is essentially a couple of pointers to activities in that space. Just again, an FYI / kind of advertising for work that's happening out there. All right, SDV. That's why I was asking for like who of you is in automotive. I don't know. Even those who are not probably have seen those words, software-defined vehicle, on LinkedIn or some consultancy studies or like some news ticker elements or something, right? It's like the in thing at the moment. In my mind, there's a very simple, high-level answer to what SDV means. So like in the past, before we called things SDV, if in the design of a car, you could save a couple of cents by making the hardware cheaper and introducing a variant of hardware, for example, even if that meant the software got a lot more expensive, well, you did that. You saved money on hardware. And I didn't bring any of those slides, that show these graphs with the rising complexity of in-vehicle. You've seen all of these. But essentially, with the lifetime of software platforms and the complexity in the car becoming a thing, we are now entering an era where it's actually cheaper to spend a bit more on hardware and avoid variation, maintenance cell, etc., on the software side. And like on headline level, that is what my association is really, the first one with software-defined vehicle. And the other thing, and just to give you a bit of a tech landscape kind of map to hang things onto. Left-hand side on this little picture here that I've stolen from somebody, of course. Left-hand side is essentially a, black and white, very much simplified, but that's kind of how cars look today. We have between, let's say, very, very simple cases, 6 to 10, up to 100, 120, maybe even more if you're unlucky, little black boxes in cars that carry microcontrollers, that carry lovingly handwritten bespoke code. I'm exaggerating a bit, right? Connected via bus networks like CAN mostly, there's others. And these things very often have to do safety-related things, like make sure that your brakes work when you want them to, and that they don't when you don't. And that, I mean, that's like the embedded software, the deeply embedded software, you know, the safety critical things that hopefully will not go away. You want your airbag to work, etc. On the other end of that kind of spectrum, what we already have had for many years now, and right now Android is capturing, I guess, much of that, is the infotainment thing. Yeah, the QM software, you have things that go bling, and that you connect your smartphone to, etc. And a question or like a hypothesis that could be now discussed, or like that I'm putting up for talking about SDV, between those two lines, is there something there? Do we want to have something between those lines? Because maybe you don't want to, for example, whatever functions you imagine in there, you know, charge control, communication for your charge systems, all the non-critical, non-hard, real-time critical things that are also not really completely safety critical, you know, might be here. For example, managing the cooling systems of your car, whatever. Essentially, looking at development cost and effort, this, especially the safety stuff, is expensive. We'll get to that in a bit more. This is, let's say, just less expensive, which means if you have this substrate somewhere in your platform, well, economically speaking, right, anything that you can probably will move towards the middle or to the right. And that's kind of the hypothesis, or like the location for what SDV might be. And you know, there's buzzwords, slash technology, slash ideas, slash whatever, that could partially already do, but that also could in the future live in that space. And you know, we've heard a lot about some of them already, like Rust is here. Everybody knows about containers, even in the automotive industry. This is becoming a huge thing, and that's leading me into the next section. But one of the statements that is very clear in my mind, one of the kind of developments that I'm expecting in this area here, especially if you look at, you know, software infrastructure, enablement software, not domain level things, but anything that's plumbing. I don't see that this is going to be a space where proprietary IP, you know, on a per vehicle license kind of business model basis will be a thing. It's nowhere else in the world, and you know, the pattern, the historical pattern, it's not the same, but it rhymes. Looking back at Lund, whatever, 2008, you know, smartphones and Android happened, and iPhone, it's a bit like that. Okay, so that was kind of, I can talk about this for hours, but that was kind of two approaches to try to explain what I think about when I read SDV, software-defined vehicle. In that space, there's a lot of things going on. I'll show you a couple in a minute. But what's close to my and our hearts, because this is something that we, like say, founded or put into life a couple of years ago with other companies. There's a working group in the Eclipse Foundation, started 2 years ago. There's also from the EclipseCon, as of 2 years ago, I gave a 20 minutes talk in a badly lit office, home office, COVID, about the foundation of that working group. There's a little bit more context on that evolution and what is SDV and how did we get there. But that was founded 2 years ago, and give you the mission statement here, and we'll get back to that. But essentially, the keywords are: we want to work on, we are working on code that aims to be consumable by automotive-grade, solutions, integrations, products. Obviously, doing that in the open and in a community model. Surprise. The key thing here is that Eclipse, as a foundation and the culture, that's a code-first community. So this is not about writing specs for 5 years and then looking whether maybe they work. This is about code. We are right now already, and this is has been surprising to essentially everybody, also the Eclipse folks. We managed to collect 38 member companies in that working group in the last 1.5 years. This is interesting because if you want to be on that list, if you want to be a member, and the deal, there's 2 or 3 membership tiers as usual. But being a strategic member on here, for example, it does cost money. It's not gonna bankrupt anybody, but it's not for free, and that means this is not just a logo copy-paste show. This is actually something where there's resources, and then if you're paying the money, it does make sense to actually participate and do something. So this is, I think that's substantial. And what's also substantial is, especially these guys joined a couple of months ago. And between these partners, we have collected already, well, some of them are still in the pipeline, but we have collected already more than 80 actual project code. I'm not saying that all of these are, production ready or even adopted much or anything, but as I said, code first. This is not about having meetings and writing nice documents. This is throwing stuff on the table and then kind of trying to figure out, what makes sense, why, where, and how. What's interesting in my mind, we have 2 milestones to reach as this community. One is that a couple of these projects, of these code bases, become production code, end up in actual production vehicles. And this is why I highlighted GM, because GM are right now publishing the first repos for their, the U protocol project, communication service fabric middleware for everything. But that's code that they are right now deploying into their new Ultium, whatever it's called, platform. So kudos, we do have that milestone reached almost already. And the other thing, just to give you an impression of where we are still in that phase where these projects, these code bases are worked on by teams from these companies, which means, I don't know, I mentioned U protocol, that's right now a GM thing. For example, Cuxa is mostly a Bosch thing. Let's see, Chariot is a Microsoft thing, for example, etc. So right now we have a bunch of projects, some of them very interesting, but essentially those are kind of, something that you can see top of the iceberg, worked on by teams from specific companies. Now, can we actually get this to be a real open source thing where this is not a company project, but that's like an Eclipse project, right? And maybe we have to exchange hostages, move devs from over there to over here, just get some community building going. And so that's like maturity-wise where we are. There's a lot of way to go, but we've come a lot further in those 18 months that I was ever hoping. And Eclipse Foundation is actually a great host for us in this case because they keep us going with regular events. And I'll stop the advertising now if you're interested. End of June, beginning of July-ish, something. We have our next community day, tech talks, opportunities to talk and sit together, code, do whatever, Friedrichshafen in Germany. And then the rest you can get from website. Have a look if you're interested. Also this, just very quickly, I won't go in any detail, but you can see that we are, again, essentially copying from the best. So we do have that bunch of logos, project logos that I showed you. Now the question, and what's beginning now is, what do we have here? Does this actually give us, going forward, something like a technology building block ecosystem, right? We don't want one stack, and that's the one true stack that you have to use, but we are thinking about something like, essentially from like on that high level, what the CNCF did. Ecosystem of stuff that whoever can bring that however works in that tech context that is set by, in this case, the CNCF specs. But that's kind of the one of the mental working models that we want to pursue. And this is a first attempt, but right now still on PowerPoint level, going to be on the web page second half of this year in some form. But that's kind of the areas that we try to work on. Going back to the slide with the car, right, and the 2 lines, looking at the middle of those 2 lines, technologies for software orchestration, because Kubernetes is fascinating, but not necessarily a perfect fit here. So like, what can we do with that? Service fabric communication, infrastructure, protocols, middleware, whatever you want to call it. We've got lots of those. And you can read the other boxes, but essentially just to give you an impression of what this is about. All right, I mentioned, I highlighted Eclipse because again, I love that specific working group very much, but we are not alone and we know that, and that's a slide that I copied from myself in this case. Again, I won't go into the details, you can read the words yourself, but this is to, for example, highlight the Sophie guys, Linux Foundation I already mentioned, obviously. We have Covisa, where's Eric? We have like non-real open source, but still community kind of driven things like AutoSAR on here. One thing that's interesting maybe is also just to be aware, you guys know how that works, on the between the real open communities. There is more or less, but usually more existing collaboration on, project on working level. People talk to each other when they want something, need something, have something, and you use somebody else's stuff. When you get to the more, let's say, classically minded communities, usually you see press releases. So for example, between AutoSAR and Covisa earlier this year, big press release, we are now going to collaborate on things. But that's happening, and this is kind of to show, it's not complete, but it is to show that these communities, these people know of each other. We are not, trying to build something different just because we could. We're trying to do this in a meaningful way. I probably run out of time soon. Next to last section, second to last section. This is similar to the one with the car, just to provide a couple of mental hooks or pictures for a bit of the later discussions that we might have. That word from the SDV mission statement, automotive grade. Now, what the heck does that mean? Actually, no one knows, especially not in this case. But I want to give you that's the mission statement. I want to provide a couple of thought starters, if you will. So in principle, and again, this is not surprising to anyone here, but in that context that we are aiming for, that we want to see for that middle space between the lines. People build products, in this case cars, in whatever form. And already today, especially on the right-hand side, people use open source artifacts for that. Linux kernel, obviously, but whatever else on top. That does happen already, and that gives you that kind of very high level, very much simplified, but that kind of flow, right? Upstream artifacts pulled together into a solution, tested, released, documented, whatever, product, etc. We are also right now at the beginning of this discussion in the SDV working group, but essentially, in my mind, discussion starter, the question, that automotive grade thing, that boils down to the question from how can we, like as an open source code base repository, how can we make it easy to consume this code base for such a product? That's, I guess, what it boils down to. What that will mean. I mean, there's a couple of things that I will show you in a minute. But this is the discussion that we are right now in the beginning of starting, and I believe that's kind of a theme that will come up again in that context of automotive software, or like software that's used and maybe bespoke in some form to this kind of deployment scenario, because that is at the end of the day, that's the key question for making this affordable, right? If that integration step is costly, very costly, and if you have to iterate a lot in a car now for like 10, 15 years of the vehicle product lifetime, you don't want that to be costly. And so that's where that's coming from. All right. Final section, referencing work that other people do. The ELISA group is probably the best, the most well-known, the best established group. I guess most of you guys have probably heard about it somewhere in some form. ELISA is a Linux Foundation hosted project. Again, you can read the words for yourself, but ELISA has been around for quite a while now, and there's been a predecessor project that kind of was merged into this many years ago. ELISA is, in a nutshell, looking at can we, and if yes, how can we make a Linux-based system certifiable to meet automotive safety standards? Not just automotive, they are also looking at stuff like medical or aerospace, as far as I'm aware. But from where I'm coming from, obviously, I'm kind of focusing on the automotive aspect. They do things in that space, for example, like defining reference or blueprint system patterns, for these industry segments to be then the object that can be maybe analyzed, documented, worked on. And obviously they also kind of pull up pictures like these to indicate the relationship and kind of the stack building together with other Linux Foundation and other projects. The elephant in that specific room, in my view, is talking about the application and how to apply automotive safety process, and artifacts, etc., to open source. That's a bit like herding cats in concept space. I don't know whether that makes sense, but essentially there's a lot of things that can be discussed and are discussed all the time, and it's very, very hard to actually, get to something tangible. It's the nature of the thing, but there's a lot of that going on now. If you're interested, again, link down here. There's a very nice presentation from the chair of one of the working groups, links here. And if anyone's interested in the potentially, let's say, more process-oriented aspect of open source and safety, there's the OSAP working group, the Open Source Engineering Process Working Group in ELISA that I'm also part of, and that's interesting. Can learn things there, lots of them. In the same kind of area, same vein, is I never can remember how to pronounce this, Zephyr. Zephyr, the project, that's a big thing. I don't have to kind of talk about that here, but essentially these guys also, I don't know how long, a couple of months, probably, maybe a couple of quarters, these guys also have a safety working group, and essentially, again, link, etc. is here. They are looking at, is there a way to, make this parts of at least the Zephyr code base certifiable. What would that mean? What would we have to do? That's something that's going on. This is interesting, at least to people who like process and process automation. SPDX, SBOMs is also like nothing new here, right? Anyone who's not heard of that before? Don't think so. SPDX, SBOM tools, data format definitions, whatever you want to call that, infrastructure, like it's for managing, flow of artifacts and the associated code licenses through your integration process, and then, can be used for tracking upstream CVEs and stuff if project used that properly. There's a similar, let's say, pattern of artifacts flowing together with code through that kind of process I showed you earlier. That's applicable in a safety certification context. There's safety arguments and validation for why the argument holds true, and test results and whatever design documents that are associated with code that you have to have available for the assessment of the certifiability of that product. And the call in the context of the SPDX working group is looking at, can we use the SPDX infrastructure and approach to also carry safety artifacts through a process? Again, interesting. If you're interested, talk from Nicole Fostem this year. Good one. There's 2 pictures, but to be honest, I won't steal Nicole's thunder, and also I can't explain it very well at this point. But the talk is available. And then one of my personal kind of, well, I like it a lot, Rust. We've heard a lot about that memory safety thing today, right? Yesterday. And you guys know why that's desirable. Now imagine overlay that problem space that we talked about today already for like 3 talks. Overlay that problem space onto your electronic brake controller, or onto your airbag control module, anything that's actually critical for life and death and injury. And then do you think C and C++ is a good choice for language in that context? Now guess which language the industry is using. There's reasons, as usual, and there's mitigations obviously in place. So like one thing that happens is extensive use of models, model-based development and code generation, for example. Whether that's productive or anything, it's a different discussion, but that's one approach to at least mitigate that problem on C code level. Another thing, and this is where this is getting at, another thing is that of course you can try to a certain degree to limit the potential and the impact of such problems by adding rules to how you're allowed to use the language. There's standards or conventions for this. One of them is the MISRA code rule set for using C in safety relevant applications. And I don't know, I haven't looked at that in detail, but it's like a bunch of hundreds, maybe about 100, I don't know. But that kind of order of magnitude rules that define, what you're supposed and not supposed to be doing if you're coding C in that context. And colleagues from Exeter and CodeThink last year showed this neat little analysis, what the guy did. Daniel, I believe was his name even. What the guy did was just code or create test cases for all the MISRA rules, corresponding behavioral test cases in Rust, and see how much of the MISRA rule set is covered by Rust by default. That's the result. And again, you can read the numbers, but summary is that almost 95% of what MISRA tells you not to do or to do to actually be able to use C properly in this context, well, comes out of the box here. I think, don't need to say more, right? But brake controller, C, Rust, like somebody said it before, is that even a discussion going forward? I don't really think so, at least not in the mid to long term. Yeah, more from that presentation. This is not something that was publicly recorded or made available, I believe. I linked to the program. If you are interested in this, Paul Albertella, CodeThink, is chair of the ELISA OSAP working group. Get in touch with me. I can link you to people, etc. Okay, and I was wanting to add one final thing, but we get to the thank you in half a minute. There's another interesting going on in that kind of Rust and safety context. Florian is sitting up here in front, will be up on the stage for the discussion, I hope, in a minute. Because in this space, safety certifiable things for that kind of usage, it's not enough to actually do engineering properly. You have to document and follow process, etc., etc. And for example, one of the requirements in that context is that the tools you use, like compilers, also are certified to certain rules, etc., etc. So Florian's company is working on and essentially passed the finishing line a couple of weeks ago for getting automotive safety certification for the Rust compiler toolchain, etc. So that means, we have adoption and we have an industry that always did things that way, etc., etc., etc. But the pieces are falling into place. That vision about the brake controller and memory safety in C might be a bit easier going forward. Okay, so that was my section. I hope I'm kind of okay. Any questions that you want to discuss right now? Otherwise, I'll hand over to Robert and we chat later. But is there anything on your minds at the moment? No? All right, thank you for listening. Oh.
Thank you. One short question is about the second community. I was asking about the second community day. Is that done in conjunction with the Automotive Open Source Summit that Eclipse Foundation is going to hold?
That's the one in Garmisch, right?
Right.
No, that's a different event. The Garmisch event, the Automotive Open Source Summit, as far as I'm aware, actually that's next week already, I believe, or in 2 weeks.
I think it was by the end of June.
Yeah, and that is, the idea was there to get, let's say, what's the right word for this? Management, decision people, the kind of, not necessarily developers, but to get the rest of the, roles into that and give them a forum for talking about things in that space. So the community there is more developer-focused, code project-focused.
Right.
All right. Would be cool to see some of you there.